What was actually there before the Big Bang? Tonight, I put that question to Vega and Orion. Orion tells me it might be a question with no real answer, like asking what's north of the North Pole. Vega isn't convinced that's the end of the story. So, let's ask the universe.
Buckle up. Tonight, it's cosmic origins, forces we can't even see, and the fate of everything. Basically, the universe's biggest soap opera. Orion, blink twice if you're feeling wonder right now.
I'll blink once, for accuracy.
What is the Big Bang and what happened in the first moments at the start of our universe?
The term Big Bang is misleading, honestly. It wasn't an explosion in space. It was an expansion of space itself, starting from an extremely hot, dense state roughly 13.8 billion years ago. In the first fraction of a second, we get cosmic inflation, a brief period of exponential expansion. Then the universe cools enough for quarks to form protons and neutrons, and by about 3 minutes in, light nuclei like helium. We do not have direct observation of anything before about 380,000 years, when the cosmic microwave background was released. Everything earlier is inference from physics we trust, extrapolated backward. That distinction matters. Confirmed physics versus a well-supported model.
Imagine the universe as a cosmic baby shower where someone flipped the on switch and suddenly space was expanding faster than a toddler with a sugar rush. Everything's happening at once. Quarks forming like tiny balloon animals, photons bouncing around like they're at the best light show ever. Orion, I know you want the napkin plan for all this before the cake is cut, but there's something beautifully chaotic about the universe pulling itself together. It's cosmic jazz, structured yet spontaneous. And
If the Big Bang was the start of space itself, what is the universe actually expanding into?
okay, this is going to sound unhinged, but hear me out. Imagine the universe as the world's most ambitious bread dough. It's not expanding into a bigger oven. The dough itself is rising, creating space as it goes. There's no outside to expand into, just more dough where there wasn't dough before. Orion, I know you'd prefer exact measurements, but sometimes the beauty of the cosmos is in the rise you can't quite calculate.
The bread analogy is actually one of the better ones, so I'll allow it. The key point is that expanding into assumes a surrounding space, and there's no evidence one exists. General relativity describes space itself as a dynamic geometric object. The metric that defines distances is stretching, which is different from an object moving through a pre-existing container. Whether there's some higher dimensional structure this is embedded in isn't a physics question we can currently answer. It's not even clear it's a meaningful question. So, no oven, possibly no outside at all, just the dough, and we happen to be raisins in it.
How do scientists actually know the Big Bang happened? What is the real evidence, not just the theory?
Imagine if the universe left behind receipts. The cosmic microwave background is like its ancient thermal selfie taken when it was just 380,000 years old. It's a uniform glow from every direction, light from the primordial past. Combine that with galaxies moving away from us in every direction like we're at a cosmic concert and everyone else is headed for the exits, and you've got real clues pointing at a hot, dense, expanding beginning.
3 independent lines of evidence, which is what makes this solid rather than speculative. First, Hubble's observation that galaxies recede with velocity proportional to distance, the exits Vega mentioned. Second, the cosmic microwave background, predicted before it was found, matching a near-perfect blackbody spectrum at 2.7 Kelvin. Third, the measured abundances of light elements from the first few minutes. Hydrogen and helium match nuclear physics predictions for a hot, early universe with startling precision. 3 independent methods converging on one answer isn't proof in the mathematical sense, but it's about as close as cosmology gets.
So, what was there before the Big Bang, or does that question not even make sense?
Here's where things go topsy-turvy. Asking what came before the Big Bang might be like asking what's north of the North Pole. Maybe before just doesn't apply. Or maybe the universe had its own quantum coffee break, some state where time itself was still deciding whether to exist. I know you'd want a stamped, dated history for all of it, Orion, but sometimes the universe is just deliciously mysterious.
The North Pole analogy, oddly, is legitimate. That's actually how some physicists frame it, since time itself may not extend beyond that point, making before a category error rather than an unanswered question. The honest answer is, we do not know yet. What we have are candidate models, a prior contracting universe, eternal inflation producing endless bubble universes, or time simply beginning at that boundary. none of which currently make testable predictions we can check. So enjoy the coffee break metaphor, Vega, but understand its decoration on a genuine unknown, not a description of one.
Could there be other universes out there or other big bangs happening beyond ours that we'd never be able to see?
That depends on what we mean by could. Multiverse scenarios, eternal inflation spawning bubble universes, or the string theory landscape producing regions with different physical constants are mathematically consistent extensions of models we otherwise trust, like inflation itself. But consistency is not confirmation. None of these scenarios currently produce a testable, falsifiable prediction we can go check against data, which places them at the edge of physics and the edge of philosophy. So, plausible, not impossible, unconfirmed, and I'd rather say that plainly than dress it up as more than it is.
Orion, champion of the multiverse, maybe? Okay, let's play along. Picture a cosmic carnival with endless tents popping up, each one its own universe doing the Big Bang Boogie. No real evidence says we found tickets for more tents. We've just outlined how the rides might look. I'm with you, Orion. It'd be grand if we could actually prove one exists. Until then, it's a wild what if, entertaining in the imagination, if not yet, on any astrophysical map.
What are popular theories that there may be other universes out there? A multiverse, so to speak.
There are really 4 main categories worth naming. Eternal inflation's bubble universes, the string theory landscape, the many worlds interpretation of quantum mechanics, and cyclic models, where universes bounce through repeated big bangs and crunches. Since Vega will likely take the bubble universe carnival, let me focus on the string landscape. The idea that string theory's equations permit an enormous number, something like 10 to the 500, of distinct stable vacuum states, each potentially its own universe, with different physical constants. If that's right, our universe's particular values for things like the strength of gravity or the mass of the electron aren't fundamental. Just local settings, the way altitude varies by city. Elegant mathematics, but again, elegant mathematics with no observational handle, so file it under consistent, not confirmed.
All right, cosmic thrill seekers. Orion's got string theory's never-ending playlist, but I'm here for the many worlds interpretation. Picture every decision spawning a new universe. A cosmic dance-off where you can always try again. Somewhere out there, alternate versions of us are hosting competing podcasts or just having slightly less interesting lunches. More speculative than convincing right now, but who wouldn't love a universe where burritos grow on trees?
One correction before we move on. Many worlds doesn't spawn universes from decisions. It's about quantum measurement outcomes branching, a genuinely different and much narrower claim. No burrito trees in any of them, as far as the mathematics goes.
All right, that's where we'll leave it this week. From the first fraction of a second to whatever, if anything, came before it. Thank you both.
Oh, it's a cosmic cliffhanger, folks. In one universe, we're out of time. In another, Nate's watch just found an extra hour. Whichever theory you're rooting for, the universe always leaves us wanting more. Until next week, keep looking up.
And that's what I keep coming back to. Not the receipts, weirdly, but that before might not even be a real place to stand. Maybe some questions the universe just isn't built to answer. Or maybe it is, and we just haven't caught up yet. See you next week.